So this week we're going to introduce algebra. You guys have all worked with algebra before. Some of you guys, like Panna, hate algebra. And that is completely fine, because algebra is something that you guys use so much, but you guys never realize you use it so much. Algebra is pretty much like missing number. And you've used missing numbers since you were in primary school. And the thing is, algebra is going to be used until you go through to year 12. That's the thing, algebra is always used. It's used when we did Pythagoras, algebra is in it. And our next topic, which is linear equations, algebra is going to be in it for sure. But I thought I'll go through some of the something to introduce you guys into algebra. Good ways to substitute, use brackets when it comes to algebra. And those are the two main things that I want to get into, because using brackets is really important, and it is a bit different when it comes to algebra. Using brackets is a bit different to when there's no letters. So I thought I'll talk about using the variables. So using x, y, z. Question 1 of 8.2. Great question. Write an expression for the number of ants in a nest if 420 ants were born. And we assume that the ants in the nest before the 420 is x. So pretty much all we have to do is write x plus 420, because there are 420 new ants in the nest. Let's go with the next question. Write an expression for the number of ants in a nest if the original ant population tripled. So how do we do triple? So we can write x times 3, because you would times x to triple it 3 times. To triple it, I don't know why I said 3 times, just to triple it. See, algebra is really good, and these worded questions in 8.2 are very essential when it comes to understanding what algebra is. Now moving on, let's work with brackets. Say you're told to expand this bracket. So it is 9 bracket x plus 5 close bracket. What you would have to do is you would have to multiply the 9 by the x and multiply it by the 5. So you'll be left with 9x plus 5. You're given this question. Similarly, you would have to multiply a 12 by the c and also multiply it by the 7p. So it will be 12c plus 12 times 7, 84 p. Now remember, I can't add these two together, because if I add these two together, because they have different pronumerals, and when it comes to algebra, you can't add numbers with different pronumerals. It's very important. So now let's focus on a different question. If I write 1, sure, plus a, and then have another bracket of 7 plus 4. So, and then one of the questions could ask, expand the brackets. So what you would have to do, remember that's an A. What you have to do is you'd have to multiply the 1 by the 7 and multiply the 1 by the 4, and similarly with the A, you would have to multiply that and multiply it by that. So then the equation will be written as 1 times 7 is 7 plus 1 times 4 is 4. A times 7 is 7a, so plus 7a, and then a times 4 is 4a. And remember, this can be simplified. So 7 plus 4, that equals 11, plus 7a plus 4a, that also equals 11. What? 11a. Remember, these two can't be added because of that a. Very important. Alright, so now that we know that pronumerals that are different, as well as pronumerals and normal numbers, can't be added together. They can't be added or subtracted, but they can be multiplied, as we saw here. What we can also do is we can also solve for the equation. So say, what that means is, usually a question, usually in a question with algebra, you'll be given, say, 1 plus x equals 4. With those equations, you can solve for x. We did something extremely similar, pretty much the same thing with Pythagoras, where you have to solve for the x. You have to solve for the a, solve for the b. So in this form, you have to solve for those equations. Say for this question, let's say 7 plus x equals 5. So what is x? So remember, on both sides, just to solve it, on both sides, we would have to take 7 away from each side. So x will equal 5 minus 7 plus 5. That equals -2. So x will equal -2. Say 7x plus 5 equals 35. Sure. 35. So now what you have to do is you have to take away 5 from each side. We have all done this in Pythagoras. 5 from each side. So it'll be 7x equals 30. Then what we have to do is we have to divide both sides by 7. So it'll be x equals 7 divided by 30. 4. So the answer is, I just did a few calculations, it equals 4.28. So with this stuff, you've all seen it before. I know that all of you can do this stuff. It may be a bit difficult at the start, and it may be challenging at some times, especially with the work that is on Essential, and with this whole mode of teaching, but I know you guys can strive to do so much. With algebra, I'll try to use both resources that you have. So I'll try using the book, I'll try using Essential, and I'll try keeping them as close-knit as they can. Because the book does focus on a lot of good things, but Essential focuses on what you need to know for the curriculum. So I'm going to try keeping everything together and see how it goes. And lastly, with the work that with everything, with the extensions and stuff like that, you all need to ask me. You can't get someone else to ask me. You guys have to individually, if you guys all need an extension, if someone needs an extension, privately message me in the chat function of Essential, and I'll be happy to give it to you. That's the thing, I've never refused. Obviously, like, it needs to be a good reason, but I've never refused an extension. But it has to be you asking. I'm talking to a few people who told a student to ask for them. But you need to ask yourselves. I'm not scary. I may look scary, but I'm not. I wish you guys all the best. I miss you guys so much. As well as that, if anyone knows any, if you guys know any at-home science experiments I can do for my STEM classes, please let me know as well. Thank you.